Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. The question is minimum swaps to arrange a binary grid. So we are given a grid of n cross n. In one step, you can choose two adjacent rows of the grid and swap them. A grid is called valid if all the cells above the main diagonal are zeros. So we can swap the adjacent rows, and the main diagonal here is something like this one. So it is called the grid is called valid if all the cells above the main diagonal are 0. So in this case here we have one here above the main diagonal, so this is not valid. While seeing this case, all the positions above this main diagonal is filled with 0, so this is a valid grid. Return the minimum number of steps needed to make the grid valid, or -1 if the grid cannot be valid. The main diagonal of the grid is that starts with the 1 comma 1, that's 1 comma 1, and n comma n comma n. They started the indexing with 1. We will take 0 in the solution. So what we can do, the main intuition comes in our mind is, first we will count the number of trailing zeros in each row, and then we will be simulating the swapping part, whatever is in the question, and we will check if it is possible to just make the grid valid. If it is not, then we will return -1, and by simulation we can find the count. So let's look at the code here. First we will store all the trailing zeros of each row in the right ones. We will count the trailing zeros in this code. We will take j will be at the rightmost index for each row. We are doing this, and whenever we will finding 0, we will increment this count, and in the end of after each row we will push into the right ones. And now comes the simulation part of swapping the rows. We will have this required, the required for the first row, the required number of zeros in the first row will be 2 if the n is 3. Similarly, if n is 4, the required number of zeros will be 3. So we can find out, we will get the intuition that the required number of zeros in the decreasing order will be from n minus 1 till this 1. So required number of zeros will be, for the first iteration, will be n minus 1 till 1. So if the right ones, if this current row, we will start index with 0. If the current row has this number of zeros greater than the required, then we will simply do the index plus plus. Otherwise, if it is not the case, we will simply run this loop where till we find the number of till we find the row having the zeros greater than the required one. If we do not find any row, we will simply return -1 because it is not possible to make the grid valid. Otherwise, and then whenever we find the row, for example in this case we require 2 zeros at the first row, but we have only 1 zero, so we will find till the row at which we can find 2 zeros, at least 2 zeros. So this row is there. When we find this row in this loop, we will find the this row, so I will be 2, and till I is greater than the index, which will be 0, we will just swap them. So we will simply just swap these two rows. So will 2 will come at this part and 1 will come at this part, and we do another swap. So 2 will come at the first position, and then the 1 will come at the first position. So this is a simulation part. So after swapping, we will simply increase the result, because this is how many times we are swapping. So for the first iteration we will swap 2 times. So, and for the next iteration we will swap 1 time. You can do this on pen and paper. You will find the rest will be incremented only 1 time after in the second iteration. So this is a code. So the time complexity will be like it will be big of n square, because we had for every row we are just trying to find whatever which rows has the required number of zeros, and then swapping them. So, and here we can say the constraint is not very high, so it will pass. So guys, if you find this video helpful, please like this video and subscribe to the channel.